Right, hello guys, and welcome back to another part of my DIY analog synthesizer basics tutorials. In this video, what I'm going to cover is the second VCF, the second voltage controlled filter, which is a SEM type clone. Now why I say type is because it's not exactly precisely built with the exact same components. Now this is a schematic from the original synthesizer expander module by Tom Oberheim. Don't need to go into the history too much, the sound speaks for itself, as they say. And yeah, and as you can see, it uses quite fairly common components, and there's not a lot to it, to be honest with you. Now what this is a 12 decibel per octave state variable filter, as opposed to a, well, you can have it, I suppose it can be a you can class it as a multi-mode filter depending on how you set it up, but it means state variable, so you can actually blend between the low pass and the high pass out on this filter. So in between you'll get a notch filter, very nice sounding filter. It was used in the OBX, I believe, and obviously the SEM, and not many others after that, apart from the new Dave Smith Instruments OB6. Very nice sounding filter. Right, anyway, I just wanted to go into having a look at the filter circuit diagram stroke schematic that I used. Now this one, as you can see, it's from EFM, Electronics for Music, and this was where I kind of got the inspiration from to build this one. Now as you can see on this version, it uses the LM13600, which is an OTA, which stands for Operational Transconductance Amplifier, or Transconductance Amplifier. It's kind of quite different from an op amp. You can't wire up these the same way as I initially thought when I first started out. Oh, let me try using one of these. No, so you have to yeah, I pretty much followed this circuit. However, the version I'm using, I used a LM13700 OTA, which is it's a dual OTA. Now if we look at my little cheat sheet here, you can see this is the internals of the LM13700, and this is the pin out. And if I show you my little board here, and this is basically a small kind of just a small handful of the components you'll need to build this particular filter. Now what we have here is some trimmers, and we have two chips there. You can see one is 14 pin and one is 16 pin. The 14 pin one is the quad TL074 op amp, and we have the dual OTA LM13700, and we have a couple of transistors here which are NPN 2N3906. You can use any other general purpose, sorry, let me correct myself, PNP transistors. And this is for your voltage control input stage. And we have here a, don't know how much light we can get on that. That is a silver mica capacitor, which is a high precision capacitor which goes in the on part of the circuit, and if you use two of these, you can use other materials like ceramics or the box polyester metal film, even polystyrene. But if you want to get that high end, how can I describe it, it's almost like a chalk wind hitting your eardrums, that chalk wind resonance, that fizzy resonance, you really need to go and grab yourself a pair of these capacitors. Now I've been using KiCad for just over a few weeks now, probably about nearly a month now, and this is my schematic which I have been compiling. And now this is how I have tweaked my own circuit from the EFM 4621 Oberheim style VCF. Now, as we can see here, again we've got pretty much standard, quite obtainable components. If we look here, what I have done on this stage over here is I've put in this this electrolytic capacitor, which kind of feeds back on the resonance stage. On the original one, on the original SEM module, it has this. On the original SEM module filter. On the EFM version, it doesn't. I mean, I kind of thought outside the box and really tried to tweak mine to get mine sounding real nice. I mean, I've got a few demos on my channel. You can have a listen to the most recent ones where you can hear as I've changed the components over, and I'll put in those. If you can look at C2 and C3. Sorry, the camera's not focusing this. Well, you put in the 220 picofarad silver mica capacitors. Even the choice of pots I've used are slightly very different from the values stated in the EFM version, because the EFM version, it has 50k for the resonance, and we have 100k on the filter cutoff, which is there basically. All these other inputs here, which you take into the Q1 and Q2 transistors, you can kind of have, I don't know, say you wanted envelope generator going into one, and LFO, etc. Whatever, any other sort of kind of modulation. On my one, what I have going in is a switch which switches between envelope modulation and LFO modulation, but I also have a FM modulation, so I send VCO2 in and I can switch between two different waveforms on the VCO2, from the triangle wave or the square wave into the into my VCF. So we have audio range FM. I haven't tried this out with pulse width modulation yet. It'd be quite interesting, but it really does get some aggressive, nice sounds. Again, if we have a look here, this is our outputs. So what I have done on my one, we have sent most of the outputs. We have 3 outputs. We have a high pass output, which comes out the first stage. We can see pins 1, 2 and 3, so that'll be our first op amp. Let's just remind ourselves the TL074 is a quad op amp, so we have 4 of these operational amplifiers inside. And what I've done is sent them to buffers. This one is not quite a buffer, this is a non-inverting amplifier here, I'll explain that in a minute. Band pass, I have sent to a just a buffer out as well, and the low pass as well, as we can see here. Now, what I had to do with the high pass stage was, because when I was changing the actual modes, the high pass was coming out quite quiet. So what I did, I kind of thought outside the box and said to myself, well, I kind of need to get a bit more gain on that. So I've put that into, I've made that, and although the high pass we can come straight out here, I've taken it into another side of the 074, the quad op amp, and given that some amplification. Now, by varying this resistor, if we have less resistance, we'll get a higher gain on that. So you can, again, these are values you can tweak about. Even here on this one, it was recommended 100k on this inverting, it's inverting a feedback loop here. I've put 47k. I've actually gone down to 33k, and that resonance just sounds sweet, just right, just in the right place. It's not too distorted. You can, it really comes through nicely. So even on the audio input stage, you kind of got to be careful with the amount of gain. So I've got a gain control, because you can really overdrive this filter. You can have it sounding quite nasty or very pleasant and fizzy sounding. So again, these are things that you can kind of play about with, tweak to your own personal taste. Don't go by exactly what I've said. But here's the basic schematic. I mean, what I'm going to do is, once I've compiled a few of these, I will try and put a link on my on the channel and drop this in for you guys. But in the meantime, check out the EFM. If I can find the link, it's the 4621 VCF. I'll try and pop that in the description part of this video. And yeah, not too much more to say about that, to be honest. So what we have here, we can see we have high pass, band pass and low pass out. The only thing I haven't touched on now is the notch output. So basically what we're doing, how this works is we will have the low pass coming out, the audio out from the low pass, and we will have the high pass, and what we need to do is to combine those two in series. So what I've done, I've done it on a switch, so I basically switch that in. When we combine the high pass and the low pass on my multi-turn switch, it turns out we will get a notch filter out. It sounds really nice, especially when you put it on sort of like sort of Reese-esque sort of bass tones. I mean, this filter is really good. I kind of prefer it, hearing it in polyphonic synths as opposed to monophonic synths, to be honest with you. That's where, to me, it really shines. So again, this is another reason why I had to adjust the output gain of the high pass to sort of get the notch sounding how I wanted it to sound. Because it's a blend of both, we have to try and get the amplitude, or the low pass amplitude masks the high pass amplitude too much. And I don't think it brings out the best of the notch, hence I set that to a non-inverting amplifier stage before it goes out. And what I have also is a multi-turn switch. Now, I got this from Mapalinus, also known as Maplins, in the UK, and it says 4-pole 3-way rotary switch. Well, if we look on that, we can clearly see more stages in 3-way. These are a maximum of 12-way. Little tip, if you buy one of these and you open up this little, take this nut off and take the little washer off, and completely open here, you will find a small piece of metal with a stopper. Now if you take that stopper out, you can actually get up to a maximum of 12-way, so you can actually have this as a 12-turn switch. So basically these switches are anything from a 1-way to a 12-way, no matter whatever it says on the packaging. And I think that, to be honest with you, that goes for all of them, no matter what kind of brand. If they've got all these, they're not going to have 12 pins on there for a reason, and they're not going to manufacture one type for each. You know, that's just kind of silly, really, for them. So yeah, so I've got a multi-turn switch, so I can swap from, say, at the moment, so I go from band pass, go from low pass, band pass, high pass, and then I have another switch which switches into notch mode, which makes the high pass, it takes the high pass. So when you're in low pass mode, you can switch into notch, and you're in low pass mode, you can switch into notch. But obviously band pass, you can't hear that, so that's quite makes it quite redundant. But yeah, a bit of a funny setup compared to how the original SEM does it, but I'm not quite clever yet to get it to. It works for me how I've got it, so yeah, all good. Again, check out my channel, and you can hear some demos. You can hear that the filter in action. Anyway, thank you guys. I may be back for a part 2 of this. If there's any questions, please leave them in the comment sections, and please give me a thumbs up, give me a like. Thank you guys for everyone who's been supporting the channel so far, and yeah, hope to catch you soon, people. Alright, take it nice and easy.